Okay, so to get the area of a parallelogram, I'm hopefully going to try and connect it to something which I already know, which is the area of a rectangle. So as a teacher, what I might do, I might have a sheet like this with lots of different rectangles highlighted, and then I'll just give one rectangle to each student or each pair of students, like so. And then what I'll ask each student is to basically draw a line from this bottom corner to anywhere on this opposite edge. So we're looking to do something like this. Doesn't matter where it goes, just draw a line up there like that. Now some will draw to the opposite corner, that's fine. Some will draw it up there, some will draw it down there. Anyway, it's fine. What we then do is we just ask the students to cut along here like so. And we will get two different shapes, one of which will be a triangle. Now this is where we give them a bit of a puzzle. Get these two pieces, put them together anyway to make a parallelogram. Okay, so they might try, I don't know, something like that, something like this, whatever, but eventually we'll see we can just slide the original piece over and get a lovely wee parallelogram like so. Alright, now the question is, what is the area of that parallelogram? Initially what I see some students do is that they try and count the squares, and they might count the full squares, and then they'll try and look for half squares or parts of half. They might try and join something like this with something a bit bigger. They might estimate, but really, because of conservation of area, the area of this parallelogram has got to be identical to the area of this original rectangle, which we know in this particular case is 6 by 5, which is 30. Length times width. So the area of this one must also be 30. Now, because of the way the highlight has been drawn on, it actually draws the attention to the two most important measurements of a parallelogram: the base and the height. 6 times by 5. Right, the next step is to get the area of the triangle. So what I'm going to try and do is get the student to connect this to the area of the parallelogram, which they have earlier connected to the area of a rectangle. Now to help do this, I might initially draw the attention to, there's two important measurements in a triangle. There's the base and the perpendicular height. That is the height from the vertex to the opposite side at 90 degrees. And then we just get two copies of the same triangle. And again, I would give two of these identical triangles to every pair or every student in the class, and just say, from there, here's your first challenge. I want you to make a parallelogram. And they might do all sorts of things to begin with. Oh, that doesn't work. Oh no, that doesn't work. And then after a bit of playing around with, they'll compose a parallelogram like that. Now, of course, we have just learned that the area of the parallelogram is base times height. Look, those are those two dimensions there, base and height. But we don't want the area of the whole parallelogram, we just want the area of half of it to give the triangle. So the area of the triangle is going to be base times height divided by 2, or half base times height. And that's why we get the area of the triangles being half base times height. Now with the trapezoid, one of the things I will draw the students' attention to is that there are three important measurements here. There's the lengths of the two parallel sides, which I've indicated with A and B, and once again we've got the height between those two parallel sides, which is always at 90 degrees, which I've indicated with H. What I'm going to try and do here is connect this with the area of the parallelogram from earlier, and all we do, again, make two copies. And once again, my challenge to the students is, with those two trapezoids, or trapezium if you're in England, is make a parallelogram. And again they'll try, oh, does that work? Does that work? No, whatever. And oh, I could do it that way. I think I can also do it that way, can I? Yeah, look at that, brilliant. Okay, this is my favorite way of doing it, so I'll keep it like that. And so what we've got here is another beautiful parallelogram. Now what's nice about this is that we already know the form of the parallelogram. To get its area, it's the base times by the height. Well, we've got the height measured there, which is h, but the base is its total length here, also this length here, which is just a plus b. So to get the area of the whole parallelogram, it's just a plus b multiplied by h. But we don't want the area of the whole parallelogram, we just want half of it to give us the area of the trapezoid. So it is just going to be a plus b in brackets multiplied by h divided by 2, or a half of a plus b multiplied by h, and that is how we get the area of the trapezoid.